In this video, we're going to summarize this understanding of energy through the cycle of how we generate available potential energy within our synoptic atmospheric system and how we move that out through kinetic energy, ultimately to dissipation. And so what we've drawn for you here already are 4 different boxes which signify the 4 different states of available potential energy and kinetic energy. And so we have 2 apiece. One is this idea of zonal energy, so zonal available potential energy and zonal kinetic energy. This is the larger scale energy factors leading to from things like meridional temperature gradients to our zonal winds. Versus then eddy available potential energy and eddy kinetic energy is the smaller scale energy, things on the size of systems. Okay, so let's go ahead and first annotate here all these different elements. And so the first thing is our zonal APE. What we're really talking about here is our meridional temperature gradients. Okay, and so the question is, how do we generate zonal available potential energy? And so here what we've got is we've got a large amount of incoming solar radiation. And so it's our differentially diabatically heated Earth that generates the temperature gradients across each northern and southern hemisphere. And so we have a large influx. So I'm going to draw a large arrow here of our differential diabatic heating that is essentially coming from the sun, right? And so our source of energy here is the energy coming in from the sun, differentially heating our 2 hemispheres, generating on the zonal level available potential energy that we see when we look at maps of meridional temperature gradients. Eddy APE can be generated from thinking about diabatic heating. Now this is a smaller source, and we're going to do just a single dashed line here. And so we get diabatic heating from our latent heat release. And so we can think on the terms of a given cyclone that once we generate clouds, we generate a little available potential energy due to the presence of that diabatic heating. And so the question may be then, well, how do we then move between zonal available potential energy and then making that available in terms of eddy potential energy? And so what we're talking about there is this is one of our primary baroclinic processes here, in that a good chunk of our zonal available potential energy gets converted to eddy available potential energy when we concentrate those temperature gradients. And so here, what's really going on is we are having temperature advection go on to drive zonal available potential energy into something that is available to a single system. And so this is a baroclinic process. Right? Because we are involving here this idea of temperature gradients and the changing temperature gradients. Taking our zonal APE and turning it into zonal kinetic energy, what we're really talking about here, this is the global circulation. And so we have a certain amount of energy going from our zonal APE into our global circulation. Right, and so this idea of zonal jets, right, whether it's the zonal jet in the tropics or in the mid-latitudes or in the polar regions, it's this idea that we have zonal available potential energy that is driving wind speed aloft. But now we've seen most of our energy is coming in from the sun through differential diabatic heating of solar radiation, going into zonal available potential energy, that through things like temperature advection and other baroclinic processes being converted into eddy available potential energy. That it's most of our energy going from this eddy available potential energy coming in through baroclinic processes as well as the diabatic heating, which may be important on individual storm levels, that is converting itself into our eddy kinetic energy. And so this eddy kinetic energy is things that are related to our circulation around lows, both the primary and secondary circulations. And so what we're really seeing here is this eddy kinetic energy, right, is our warm air rising and our cold air sinking. That's the manifestation of converting this eddy available potential energy into eddy kinetic energy. And so again, this is another baroclinic process. Here we are just realizing that, and so we are basically using up that baroclinic instability that has been developed in our eddy available potential energy. Finally, we can also get, as we saw in a previous video, movement of zonal kinetic energy to eddy kinetic energy. And this is our primarily barotropic process. And so this is where we get eddies developing off of the flow. And so we're starting to now see everything go on. And so this barotropic process is largely to do with things like jet streams. Not the jet streams itself, but eddies that emanate off of the jet streams that are realizing this idea of large-scale zonal kinetic energy, fast-moving winds, to generate smaller circulation eddies, whether in the positive or negative sense here. And so again, remember, we can either create nor destroy energy. We're just moving it around. And so we have to close our loop, right? We have this incoming energy from the sun, a little bit from diabatic heating and important processes here. And so our main process then for slowing down the wind at the end after we've utilized our available potential energy is through frictional dissipation. And we get just a little bit of frictional dissipation. From our zonal kinetic energy, and then most of our frictional dissipation from our eddy kinetic energy, right? And so it's that spinning down of those lows at the end of their life cycle that is causing then that energy to move into a heat process through frictional dissipation. And so this diagram illustrates the movement of energy through our system, of which we can attach various isentropic or PV or QG related things going on to help this energy cycle move through. And so we can neither create nor destroy this energy, but it does move around our global atmospheric system, being available at certain times to certain types of energy conversions that then allow us to realize that energy in weather creation, whether that be our low and high pressure systems or other larger scale global circulation systems. This is just another way of getting at this idea of how the atmosphere is structured and all connected to each other and moving energy around our system to drive our weather. That's it. Thanks for watching.